This is the introduction to your extended project Codebreaking programming task. Your team firstly needs to write programs in Codebasic to encode and decode messages using the Caesar shift, which you talked about in your presentation. You can type your message into a text file using Notepad. Then the encode.bas program will read it, ask the user how many places to shift it, do the shift, and save a new version of the message in shifted format. In my diagram, I've called it coded.text. The coded text message can then be emailed or copied to your colleagues, and anyone intercepting it will not be able to easily understand it unless they know how many places it's been shifted and they have a decode program. Your decode.bas program reads the shifted message and asks the user how many places to unshift it. Then it decodes it and displays the decoded message to the user, or writes it to a file. The second part of the project is to write an analysis program which takes a coded message and helps you to decide how many places it has been shifted. It's up to you how you do this, but here are some ideas. 1. Print out the letter frequencies and compare them to standard English. For example, E is usually the most common letter, so see how much further down the alphabet your most common letter is than E. So in this case, E is the most common letter and J is the most common letter in the message. So E, F, G, H, I, J. That's 5 places it might have been shifted. Another idea is to draw a bar chart of letter frequencies and compare it with standard English. This might mean writing letters and numbers into a text file which can be read in Excel and analysed and charted there, or you could try to produce an on-screen chart like I have in your Codebasic program. In this case we can see that my standard messages here, E is the most common letter, and that's got the highest frequency here, the highest bar. In the coded message, these asterisks here, that's the biggest bar. So if that was the letter E, it would have been shifted in this case 9 places along, so it might guess that the shift was 9 places for this message. If you're feeling really brave, why not have a go at analysing the correlation of letter frequencies for all 26 possible shifts and seeing which one correlates best with standard English. In this case, I've done all the different shifts. I've worked out the correlation between the orders of the letters in the message and the orders of the frequency of the letters in standard English, looked at the correlation between the two, and we can see in this case that with a shift of 9, the correlation between those two was 0.9214. So the closer this is to 1, the more likely the shift is correct. Obviously when you decode it, you're going to need to use the negative of this shift, in other words you're going to need to move it back 9 places. So what I've got here is effectively a list in order. So 9 would be the first shift to try, then 24, then 20, then 22, then 5, and so on. So it's kind of, it's just a probability of which is the most likely shift for this particular message. In the next few videos, I'll talk you through some programming techniques to help you to complete this task.